Good day, everyone. I'm Sir RJ Leeson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about finding the domain and range of a function. Now, in function notation, we say that the domain is the set of all inputs. So that means that is the value of your x. Now, the domain also defined as the independent variables. That means using the set of all inputs, now when we transcribe it into the function rule, the range is the result of the set of all outputs. Again, the domain is the input. Using the function rule, the range is the outputs. Just like a function machine, when you input an x, so we have here input x, the function machine is the function rule, and then the result will be the output or the y or the f of x. We can also say that y is a function of x, which is y is equals to f of x. The notation of f of x class does not mean that we need to multiply f by x. In other words, f of x denote as the y value range that is equivalent to y na class. So y is the same with f of x. So that functions of f pairs with values of x or the domain. Thus, for example, f of 1 denote as the value of y, that is f of 1 is the value of y at x is equals to 1. So for example, you have a given, find the value of y given x using the function notation. So that means, for example, x is equals to 1. So instead of using y there, you will use f of x. So that means f of 1 is equal to the value, and that means the value of your x there is equal to 1. Again, the domain is the set of all inputs that is the independent variable. Using the function rule or the function machine, the result will be the range is the outputs. That is the set of all outputs or the dependent variables. Okay, let's try to express each statement using a function notation. How many liters of water are wasted when the faucet runs for 10 minutes? So we will now here find the f of 10. So that means we will find here the liters, the number of liters of water, which is your x here is 10 minutes. And your y here is how many liters? That is right. So find the f of 10. So again, it doesn't mean that you will multiply f by the value of your x, which is 10. Okay. Next, find the value of y that corresponds to the value of x is equals to 14. So we have here, find f of 14. So our y here is f of 14 and our value of our x here is 14. Next, we have y is 300 when x is 40. So we have here f of 40, so that means f of 40, your x here is 40, right? So f of x equals to the value of your y, which is 300. Okay. So for example, so we have here a given equation. So if f of x is equals to 6x plus 10, let's find f of negative 2, or the value of your value of your x is negative 2. So using the given function nato class, we just need to substitute the value of x there. So f of negative 2 is equals to 6 times negative 2 plus 10. So what is f of negative 2 now? So 6 times negative 2, we have negative 12 plus 10. Negative 12 plus 10 is negative 2. So that means the f of negative 2 is equal to negative 2. So that is the value of your y. Next, find the f of 1/2 using the same function class. F of x is equals to 6x plus 10. So substitute the value of 1/2 there sa x. So f of 1/2 is equals to 6 times 1/2 plus 10. So 6 times 1/2, we have 3. What is the half of 6? So that is 3. So 3 plus 10 is equals to 13. So that means f of 1/2 is equals to 13. Using the given function 6x plus 10. Another example we have here, if f of x is equals to 5x squared plus 3x minus 5, find f of 0. So all you need to do, the value of your x here is 0. So substitute the all values of x to 0. So we have f of 0 is equals to 5 times 0 squared plus 3 times 0 minus 5. So 0 squared is 0, 5 times 0 is 0, and 3 times 0 is 0 minus 5. So our f of 0 here is negative 5. Next, find f of 5 when your f of x is equals to 5x squared plus 3x minus 5. So the value of your x here is 5. So substitute all the value of x sa 5 class. So we have f of 5 is equals to 5 times 5 squared plus 3 times 5 minus 5. So 5 squared is 25. So 5 times 25, we have 125 plus 15 minus 15, we have f of 5 is equals to 135. Now, in finding the domain of range given a graph, the domain of a function is the set of all possible values of x, the independent variable, and the range is the set of possible values of y, that is the dependent variables. So we have here a given graph, no? We have here a given graph. Observe that the graph extends infinitely. Why it extends infinitely? Because of the arrows, diba? In both directions. This means that the value of x can be set of all real numbers. Similarly, the set of all possible values of y also is the set of all real numbers. So we have here also, we used a solid line. So that means it extends man to the value of x infinitely. At the same time, into the y-axis, the x-axis, it extends infinitely. And at the same time, in the y-axis also, it extends infinitely. That means the domain is your x, right? So that means your x such that x is an element of real numbers. The r represents the real numbers. And also in the range y such that y is an element of all real numbers based on the given graph. Now we have here some examples in how to identify the domain of range of the given graph. Another examples. So for example, we have here, determine the domain and range of the given set of points plotted in the Cartesian plane. So we have here points, no? So we have 4 and -1. We have 2 and 0. We have 0 and +1. We have -2 and +2. And we have -4 and 3. So all we need to do first, we need to enumerate the set of ordered pairs. So we've already identified the set of ordered pairs here. So when you say a set of ordered pair, that means it includes braces, right? So don't forget, when you enumerate the set of ordered pairs, don't forget to put braces in your set of ordered pairs. We have -4 and 3, -2 and +2, 0 and +1, +2 and 0, and 4 and -1 based on the given graph. Determine the first elements of x values or the abscissas of the ordered pair. So these are the set of all inputs or the domain. So that means your first terms in your set of ordered pairs or the value of your x of your ordered pairs, that is the domain. So that means your domain here is -4. Don't forget to put braces. -4, -2, 0, 2, and 4. And then when you identify the y values or the ordinates, we need to determine the second elements of your ordered pairs. That is the set of all acceptable outputs or the range of our given ordered pairs, which are, we have here the range is the second element, +3, +2, 1, 0, and negative 1. So that means the domains are negative 4, negative 2, 0, 2, and 4. And the range are 3, 2, 1, 0, and negative 1. So let's determine the domain of the range of a function described by the graph at the right. So we have here an example. Okay, let's dissect each examples. So to determine the values of the domain visually based on the given graph, consider the x values or the inputs that I taken in the graph. Looking at the values of x horizontally, diba? This is the x-axis. Now, you look at the points or the graph class. So looking at the breaks of or gaps in the graph where it begins and where it ends. So you look at no breaks nor no gap in x values. Why is it no gaps and no breaks? Because it extends infinitely in both sides. So since the graph goes infinitely to left to right without any gaps, the domain is the set of all real numbers. So pag ana class, pag opening, now you look at also the opening of your graph. If it opens upward and downward, so that means the set of all such that x is an element of all real numbers. So that means the set of all real numbers is your domain there. Now, in finding the range, for the range, you look at the y-axis. Diba, mauni ang y-axis class? Looking vertically to see if there are any restriction. Now, you look at the lowest value of your y. So what is the lowest value of your y? That is negative 4, right? Since the lowest value of your y is negative 4 and the graph extends infinitely upward, diba? Opening pa upward man siya class, then we can say that the range is all real numbers greater than or equal to negative 4. So that means the range will be y is an element of real numbers such that y is greater than or equal to negative 4. So that's how you identify. You look at the y-axis class. Okay? Another example. So example in the graph, no, in the example number 2, no, this graph, no, you look at the graph, no, naa siya the arrow and naa siya point here. So determine the domain visually. Consider the values of your your inputs taken by the graph. So looking at the x values horizontally. So we have here the x-axis. Looking at the breaks, no, you look at the point. The lowest value of your x is 1, diba? Siya nitungod siya sa 1. So that means the graph breaks at 1 or the x values. This means that the highest value, the x value is 1. The graph goes infinitely to the left starting from 1. Therefore, the domain of the set of all real numbers less than or equal to 1 in set of notation. So we have here x is less than or equal to 1. So opening, downward man siya class, paubos man ang atong graph. So that means that's why we put less than or equal to 1. Next, in finding the range now, you look at napod sa y-axis. Now, if you see that the highest value of your y-axis based sa atong point class here in 2, right? So since the highest value of your y is 2, the graph goes infinitely down starting from 2. Then the range is the set of all real numbers less than or equal to 2 in the set of notation. So we have here y is an element of real numbers such that y is less than or equal to 2. So we have here another example class. No, as you observe in the graph, there's no arrow na. So that means there are restriction, diba? And then here, na shade ang point and this one is wala na shade ang point. So how can we identify this one? So in determining the value of your x values or inputs taken by the graph, looking at the x values horizontally from left to right. So from left to right. So looking at the breaks of the graph, so you look at here, asa man ito nung sa x-axis siya class, sa negative 3. So that means the lowest value of your x value is negative 3. And then, into the right ta, so in your x-axis also, there is a hole at 2. The highest value of x is almost 2. So that means 2 is not included class. So take note that the solid point or the solid point here is negative 3 and negative 5. And the hole at point is 2 and 0. So that means the lowest value of x value is negative 3 and the highest value is almost 2. So that means, hence, the domain of the function describes the graph of the real numbers greater than or equal to negative 3 but less than 2 in the set of notation. So that means the set of all elements of real numbers such that negative 3 is less than or equal to x less than 2. Okay, take note class, in identifying the domain and function given a graph class, if solid ang atong point class kanang naka-shade, that means you will use greater than or equal or less than or equal. Pero if open siya class, like whole lang siya, wala siya gi-shade, so you will use less than or greater than. So that's how will you identify that. So for the range also, we need to look at in the values vertically. So what is the highest value? Asa man ang peak nato class sa you look at the highest value and the lowest value also. Since the lowest value, so if you the breaks here in negative 5, that is your y, diba? And then in the highest value of your y also is positive 4. So that means the range of the functions is all the real numbers greater than or equal to negative 5 but less than or equal to 4. So we have here y is the set of all elements of real numbers such that negative 5 is less than or equal to y less than or equal to 4. Since your lowest value is negative 5 and your highest value of your y is positive 4. So that's how you identify the domain and range of the given function of the graph. So another example here. So you look at here the example, no? So when you identify again, how can we identify the set of all domain? No, the domain first. So you look at the x-axis from left to right. So asa man na determine ang atong x values class from left. So we have here in negative, between negative 2 and negative 4, so that means negative 3. Until to the right, nato nga point is positive 3. So that means when you write the notation for the x domain or the domain is x such that all set of all real numbers such that negative 3 is less than or equal to x less than or equal to 3. Why is it we use less than or equal? Because the point here is solid point. Okay? Now, in finding the domain, the range, so we will now identify it by its y-axis, no? So what is the lowest point and the highest point? So the lowest point is in negative 2, and then in the highest point, so where is there? So we have here y is positive 3 in y-axis, right? We have here y is an element of real number such that negative 2 less than or equal to y less than or equal to positive 3. Next, you look at here the second graph. So how can we identify the domain and the range? So we have here the domain. So you look at the x-axis. So asa siya natungod to negative 1. And then into the right siya into positive 3. So that means the set of all elements of real numbers of x such that negative 1 less than or equal to x less than or equal to positive 3. Now you look at next into the range. So where is the range here? So the lowest point niya is naa siya sa 0 ang atong y. And then the highest point is naa siya sa positive 2 sa atong y-axis. So y is an element of real numbers such that 0 is less than or equal to y, less than or equal to 2. Next example we have here, you look at the graph. So we have here from left, so we have in the negative 3 ang atong x, and ang atong y is out. Ang atong x to the right is in the positive 3. So that means the set of all elements of real numbers such that negative 3 is less than or equal to x, less than or equal to 3. Now you look at next to the range, what is the lowest point of your range in the y-axis, no? So naa siya sa negative 2. And then the highest value in the y-axis is positive 2. So that means the set of y elements of real numbers such that negative 2 is less than or equal to y, less than or equal to positive 2. No, you need to remember in finding the range, you need to find the lowest value of your y and the highest value of your y. So we have here finding the domain of the range of a function given an equation. So here in the equation na, so we have here f of x is equals to 5x plus 6. There is no values of your x here. That makes that the function of f undefined. Therefore, the domain has no restriction. It is the set of real numbers, and the range also is the set of all real numbers. This is x. Okay? So that means when you write the domain, if given a function class, pag linear class, linear, what is linear function? That means the highest value of your exponent is 1. That is a linear function. If linear function class, directly you will identify the set of all elements of real numbers of x. Same with the range, the set of all real numbers ang atong range class, the value of your y. Now, what if quadratic class? For example, quadratic f of x is equals to x squared plus 4. So that means for every values of x makes the function f defined. Therefore, the domain of the set of all real numbers. So again, the domain directly, since ma-define man siya ang atong mga values, when we substitute the value of x, the f values will define. So that means that the domain is directly the set of all real numbers. And the range is the set of all positive numbers greater than 4. So how will you write this one? If quadratic class, quadratic means that the highest value of your exponent is 2. So directly the domain, direct class, the x is element of real numbers. While in the range, to identify, so y is greater than or equal, what is the value, your constant term there, you put there. So that is y, the set of all real numbers such that y is greater than or equal to positive 4. So that's how you identify using the quadratic. Now, what if naka-radical class, f of x is equals to square root of x? For the function involving the square root to be defined, the radical should be greater than or equal to 0. The domain of the set of all positive integers or positive numbers including 0, since the square root of a number is at least 0, then the range also is greater or equal to 0. So that means pag naka-radical class, your value directly, that means your domain is x is greater than or equal to 0, and your range also is the set of all y such that y is as greater than or equal to 0. So positive values. Again, if linear sa class, directly the domain is the set of all real numbers, the range is the set of also of real numbers. If quadratic, the domain is x such that the set of all real numbers, the range, so there is a restriction, no? So you will identify the constant term, so y is greater than or equal to 4. So you look at the last term or the constant term. And if radical class, naka-radical siya, directly that the domain and the range is greater than or equal to 0. So you need to take note of those three. So let's try this one. So we have here f of x is equals to square root of x plus 7. So naka-radical siya class. So that means your x here must be greater than or equal to 0. So we denote now here x plus 7 greater than or equal to 0. So transpose natin si positive 7 to the right side, mahimong negative 7. So x is greater than or equal to negative 7. So that means the radicand should be greater than or equal to 0, no? Ato na nang gi-define atong ika-third na to nga example. So that means the domain or the value of your x is the set of all elements of x such that x is greater than or equal to negative 7. And the range here, since the restriction is based on the definition nato sa radicand class, y is greater than 0. So your range is y such that y is greater than or equal to 0. Next, another example, naka-radical na pod. Square root of 3x minus 5. So, pag naka-radicand, directly greater than or equal to 0. So, 3x minus 5 greater than or equal to 0. Transpose negative 5 to the right side. So, we have here 3x greater than or equal to positive 5. To find the value of x here, to isolate x na lang, so divide both sides by 3. So that means we have x is greater than or equal to 5 over 3. So that means the range here is x such that x is greater than or equal to 5 over 3, the domain, and the range is y such that y is greater than or equal to 0. Okay? Ana lang pag-identify class using the given equation. Next, f of x is equals to x squared plus 10. Now, this is a quadratic. Why is it quadratic? Because the highest value of your exponent is 2. So, if it is quadratic function, the leading term is positive, the range is greater than or equal to. So, you need also to identify class if positive class ang atong value sa atong leading term, so that means greater than or equal. Pero pag negative sa class, you will use less than or equal. Since positive man atong example, so that means the set of all real numbers, no? X is such that the set of all real numbers siya diretso sa domain. But in the range, no, nasa restriction, y such that y is greater than or equal to 10. So when we will use greater than, if the leading coefficient is positive, and then you write the constant term for your range. Next, another example, we have f of x is equals to negative 4x squared minus 8. If the quadratic function and the leading term is negative, the range is less than or equal. Class, the domain, diretso pag quadratic, the set of all elements of x such that x is element of real numbers. For the range, so since our leading coefficient is negative, so you will use less than or equal. So y such that y is less than or equal to negative 8. So you will put here the constant term. So for your activity, so you need to answer, you copy this one into copy and answer. Write this one sa yellow paper. So you can pause and then take a screenshot. And then next we have here, you just need to find the domain and the range. List down the domain and range in the first part. And then in the second part, you need to identify the domain and range given the graph. Next, here, find the domain of each function given the equation of the function. So complete also the following table using the function given and then identify the domain and the range. Thank you so much for watching. I hope that you've learned something out of this lesson. That's all for today. Goodbye, everyone.